This is our R1. Okay. So what am I doing? I'm first giving an IP interface is 0 by 0, IP address 12 dot right, not share. Okay. Interface is 0 by 0, IP address 12.2.5.2.5.0, right? No, sir. Okay, I'm also creating one interface back IP address. Okay, now check here. I'm only having one route that is connected, that is 12 network. It is directly connected. Okay, other than this, I don't have any route. No, right? It will not be able to ping. Why? Because it doesn't know where 8.8.8.8 is, right? It is not able to ping. Success rate is 0, percentage is 0. IP route 0.0.0.0, 0.0.0.0. This is our next route, right? I gave this route. Right? See here. What is this star? Can you read that? Candidate default. That means that it is a default route. It is a default route. Okay. So see your network 0.0.0.0/0. It means that whatever the network is, forwarded to 12.2. Okay. Earlier it was not able to ping. You are getting it?
Yeah.
Default interface L2, IP address 2.2.2.2, right? Two dot two dot two dot two, right? There is no route for 2.2.2.0 network. Ping. Is it able to ping?
Yes.
Success rate is 100%. Why? Because of the default. The router has checked for any matching routes entries are there. It didn't find. It has chosen default towards 12.0.0.2. Right? So this will be the default. Okay. So okay. Split horizon. Split horizon.
Horizon.
Split horizon, horizon.
Horizon.
Okay. Split horizon, huh? Can you read this? Router will never forward an update that it received on one interface through the same interface until and unless it received the best update from any other interface. Right? What I meant is, okay, right? This is my network X. My network, my router R1, my router R, right? When we are running distance vector or else the dynamic routing protocols, right? Dynamic routing protocols, usually distance vector routing protocols. Okay, what will they do is, okay, so actually why we came up with split horizon, why the need of split horizon, I'm explaining you. Okay, first thing is, this router R1 will tell or will send an update, will send an update to R1, to R2. R1 will send it to R2, saying that, hey bro, if you want to go for X network, if you want to go for X network, you are just one hop away. One hop away. One hop in the sense, one router. Okay. So if you want to reach X, you need to go through one router. Right? It gave this update to my router, gave this router, or this router R1 has given that update to R. Right? Now R2 will check that update. R2 will check that update. Now it will broadcast that update on all the interfaces.
On
All the interfaces.
okay.
So what will it do is, it will forward the same thing. He will tell the router over here, the router over here, the router over here, the router over here, and the router over here, and same update to the router over here. That if you guys need to go to X network, if you guys need to go to X network, you are just 2 hops away, because it got update with 1 hop, right? And this is also one of the hop, right? This is also one router. It received that. If it has to go to X network, in between there is an one router. Now it will include itself, and it will tell remaining routers that if you have to go to X network, you are just 2 hops away. Okay. So he received the update, that 2 hops. Now this router again, it will send the update. If you have to go to X network, it received update with 2 hops, right? So it will send update with 3 hops. It will add itself. Now it got update with 3 hops. Latest one. 4 hops. 5 hops. 6 hops. Like this, where does it go on? Like this loop of updates, where does that go on? Can you read this? Infinite. Usually we call it as count to infinity. Count to infinity. There is no end, right? So it will keep on updating with adding place 1 hop. It will also keep on updating with adding 1 hop, right? Like this, the loop occurs, loop of updates occurs, and that loop that updates keep on roaming in that loop itself. Okay. In order to avoid these loops, in order to avoid these loops, in order to stop this process of count to infinity, we came up with split horizon. Split horizon, right? So what it is saying? Router will never forward an update that it received on one interface through the same interface. Now it got the update of 1 hop. In order to reach X, it has got update of 1 hop. It will tell that information of 2 hops to all the interfaces on it, except this interface. Why? Because it has received this update on this interface itself, so it will not forward the update. Okay, but on one condition: until and unless it received the best update from any other interface. Okay, for suppose think that okay, for suppose think that this router has given an update that if you want to go to X network, you are 5 hops away, including it. including it, it told that 5 hops away. Okay. So on this interface, F0 by 0, this is my 0, F0 by 0, it received an update of 5 hops, right? But it received update of 2 hops, update of 2 hops on the interface F0 by 2. On the interface F0 by 2, that is this interface. Now which one is the best one? The 5 hops or the 2 hops? This is the best route. Why? Because less number of routers. Right? It has to pass through only less number of routers, only 2 routers. So it got an best update. At this time, it will update this router on this interface. That you told me if I want to go to X network, I have to go 5 hops. This was update given by you, but I got one best route than yours. That is 2 hops. So now you update your routing page. It will be 3 hops. Done. This is splitter. Not sending the updates through the same interface on which it received, but it will send updates only when it gets the best route on the other interfaces. It's called splitter. Got it?